Recall the TensorFlow computation graph that we saw in the last example, in the previous session. I had the house size, the size factor, and the price offset. So basically, this is data for predicting house prices, where price is the variable that I'm interested in predicting. So I multiplied these two, I added that, and I finally got my prediction, right? So a typical neural architecture works on the same principles. So I have these inputs, I have these weights, and I'm going to multiply the input with my weights, like here, I times W. I'm going to sum it up. So sum up all of this, add the bias, and then put it through an activation function, namely sigmoid or a tanh or whatever, and then finally receive my output. Okay. Now the neural network learning that is going to happen is we are going to compute the loss here, loss or the error or the cost, and then we are going to optimize to minimize this loss function. Okay. So when we initialize these weights, whatever strategy we take to initializing them are always going to be erroneous, right? So there's going to be a lot of mistakes that we are going to make upfront. First, we need a strategy to measure that error. Once we've learned how to measure that error, we will use some optimization like a gradient descent or a back propagation to readjust these weights and then try predicting again to see that the loss is decreased or not. And learning is an iterative process like this. So we make a prediction, we compute the loss, we update these weights and biases, we again do some predictions, compute the loss, readjust these weights and biases, and so on. Okay. So if I revisit the linear regression example that we did last session, this is some TensorFlow code that we stepped through, wherein the prediction is nothing but the multiplication of the size factor and the house size added up to the price offset. Okay. How did we compute the cost? We were doing squared errors. So our prediction minus our true price squared, sum it up, and then divided by the number of total training examples that we saw. Okay. We used gradient descent optimizer with a learning rate to minimize our cost.